Today I've been messing with a few electric motors. So these two are little shaded pole AC induction motors, and essentially what that means is that you see these little hunks of copper next to the rotor. These suck some power up and release it a little bit later so that it delays it so that it has a spinning rotational field so that they can self-start. This is a low efficiency way that's cheap. They're using small motors like these. Thing is, these are almost always 120 volt 60 Hz AC motors in the area where I live. So I've tried messing with a few of them. So this is the first one I did. I removed all the coils here. So you can see all the standard coils, which kind of would look like this, but just have a lot more of them, have been removed. And I put this in. This is from an old inductor. And you can notice one thing really quickly. This is not a lot of coils here. It does work. This motor does spin up. The problem is this is the rotor and it got bent. So it won't spin very well at all, but it will have a little bit of torque before it gets stuck on the bad bearings and the bent rotor. This is my next experiment. This guy was a lot more careful and actually unwinded every single turn instead of just cutting it all off and replacing it. I took off there's roughly one layer left, which I think if I go and measure it now is roughly equivalent to, I want to say like 2 ohms or something if I go measure it now. Yeah, okay, so it's a bit under that. It's 0.7 ohms according to this multimeter. It's hard to measure low resistances very well though. So let's go test it at some low voltages. This guy should work fine on 120 volts, but it's going to suck a lot of current and power. So we're going to try 12 volts. I have a linear 12 volt power supply here. We're going to try this guy first, and then we have a current meter and some voltages and a few other meters we can look at once it's running. So everything's ready for testing now, and now I'm going to flick the power on. 12 volts, and you can see it spins up just fine. What I'd consider normal torque. Normally these have very low starting torque. The one thing I notice is this gets really hot, so I can't run it for any sustained periods of time. 12 volts, standard sine wave, starting to get toasty, and it's pulling roughly 6 amps. So you can notice it runs fine. That's pretty much the standard speed. I don't have an easy way to measure RPM, but that sounds just like what it should be. And feels like the other thing is this guy gets really toasty. I should find a way to cool it. You can see this is burnt plastic from earlier right here, because it actually melted the plastic because I ran it for like 20 or 30 seconds, a little bit too long. But it does run fine. So for a little bit more experimentation, let's stop using this guy, which is 12 volts. AC 60 Hz, and use this audio amp under it. I have a tone generator on my phone that I can do relatively low frequencies with. We're just going to generate a tone. We can change the voltage with how much output it is. It's a bit low for this amp, the resistance, but it won't kill it now. So now I have a frequency generator on my amp outputting roughly 60 Hz, and let's see how she goes. So we can see now the motor and the multimeter behind it. So if I keep bumping it up, I'm at about 2 volts now, roughly 2 amps. And we're starting to spin slowly at about 5 volts, 3 amps, that's 15 watts, mostly heat. And we get the full RPM at roughly 7.5 volts and 4 amps. And we can see here frequency is 63 Hz, spinning pretty fast. And now if I go on my phone, I can go on my phone and change the frequency now. And you will notice the sound change. So here I'm now at 73 Hz, 83, and it'll keep going a bit faster until it doesn't have enough power and starts to break slip. So you can notice I've done it now, and now it's just buzzing. So after finding out that my amp doesn't really like to drive it, we're going to give it one last shot and see how much power we have, and then we might burn it out for kicks. So currently 9 volts, 5 amps, we're going to slowly bump up frequency. Let's see if we can bump it up. Current actually goes down as RPM goes up. So 13 volts, 5 amps. Should be spinning quite a bit faster than normal now. And yeah, that actually feels like it's quite a bit more torquey too. Yeah, that is quite a bit more torquey. Let's see if we can pump anything more out of this before the amp craps all over it. So 130 Hz. And yeah, it won't do 130, at least not at this voltage. 20 volts, 8 amps. Yeah, that's doing it. So there you go, a bit of motor modding. Should be spinning about twice as fast as it should be. It should be roughly 6,000 RPM if I'm right. Yeah, that could be 6,000. Probably more like 4 or 5 though. We're gonna kill it now before it craps all over itself. Yeah, might as well kill it for fun. Because this might be new here. Nope, this is old. Fan helps cool it a bit. So basically the modding of these is remove coils and to run on lower voltages. Same with adding it. If you're running this few coils, the problem is this is really thin wire, so it actually has a pretty high resistance for the amount of magnetic field it can create. So what you should do is you should put thicker wires in, so more like this guy, and it's thick wires. This guy needed like 30 amps, so at 12 volts. But it will do it. What else? You know what? Just for fun, we're gonna go kill it. This is gonna smell horrible. We're gonna go kill it. Here's the destruction setup. Here's a big 12 volt AC power supply, current meter, and a little motor which is gonna be killed. Should die pretty quickly. It'll be fun to watch. So as you saw in the last clip, the wire got really hot and burnt off. That doesn't stop me, I resoldered it on where it failed, so let's give it another shot. So one more rewind. You can see here I rewound it one more time with this really thick wiring that's not very long. It's about 0.08 ohms from everything I can measure. And yeah, it does work if I spin it up now. The only thing is it pulls about 44 amps, and it smokes, and pops the fuse. Yeah, so I keep trying to kill it, and it pulls roughly 50 amps for 3-4 seconds, and then it blows its little breaker on this power supply. Yeah, it gets hot. My wires are getting quite hot too, so I'm gonna call it quits for today. Yes, this does work. You can wind the motor like this. Don't do it. Doesn't work well. So thanks for watching. Subscribe for more weird electronic videos like this one.